already know what a galvanometer is. It's a device for converting, it's a device for measuring very small current. And an ammeter, we say it's a device for measuring large current. But there's something you can do to a galvanometer. You will be able to measure large current. And what you can do is to connect a low resistance wire in parallel with this galvanometer. With that, you can now use this galvanometer to measure large current. This low resistance wire you are connecting in parallel to the galvanometer in order to measure large current is what we call shunt. Is what we call what? Shunt. A shunt is a low resistance wire connected in parallel with a galvanometer for converting the galvanometer into an ammeter. It is a low resistance wire connected in parallel, must be connected in parallel with a galvanometer in order to convert this galvanometer into an ammeter. And the idea that you will now use this galvanometer to measure large current. The idea is, the other idea is that normally galvanometer cannot take large currents. The way it was designed, it cannot take large currents. But when you now take a resistant wire and connect it with a galvanometer in parallel, when this large current is coming, because this galvanometer and this resistance are connected in parallel, there will be current drop. There will be current drop. There will be what? Current drop, and some current will pass through the what? Low resistance wire, while the galvanometer will do what is able to do. What we are interested in doing is, if you have a galvanometer of a certain resistance, now what value of resistance wire can you convert with this galvanometer to be able to measure a certain current? What we want to do now is, if you have a galvanometer that can measure a certain current and he has his own resistance, this galvanometer, what value of low resistance wire can you connect it in parallel so that you'll be able to measure a certain amount of current? So we are looking for the value of this low resistance wire. We are looking for the value of this shunt. That is what we want to do. So let's quickly do that. For example, you say a galvanometer of resistance 5 ohms. So the galvanometer has a resistance of what? 5 ohms. Now it gives a full scale deflation. That is, the highest current it can measure is 50 milliammeter, nothing more than that. Now, it's a full scale deflation when current flows of 50 milliampere flows through it. How will you convert it to an ammeter capable of measuring 2 ampere? Can only measure 50 milliampere, not even to 1 ampere. And we're not asking it, how will you, what are you going to do to make so that it will be able to measure current of 2 ampere? Now, if you look, this is a diagram that captures this example. This is like represent the galvanometer. The resistance is 5 ohms. The current that can give you a full scale deflation is what? 50 milliammeter. And 50 milliammeter is for the SI unit of current. To get current is 50 milliammeter. To get your current in ampere, you simply divide it by 1000 to get ampere. 0 strike 0, that is 0.05 ampere, which is here. So the current in the SI units that the galvanometer can take is 0.05 ampere. Now we are now looking for this resistor. The question is, what is the value of R and what setup? It must be in parallel so that the current drop. You are looking for the value of R that you connect it in parallel to the galvanometer that will be able to measure a current of 2 ampere. Now, to get the value of arrow, what you always do, what you should get in the back of your mind is that when components are connected in parallel, we say they are at the same potential difference. They are at the same potential difference. That is to say, potential difference at the galvanometer is equals to potential difference at the resistor. The resistor or the shunt, whichever way you call it, because we have defined it is the resistor, it is the shunt. This is a low resistance wire. The potential difference at the galvanometer is equal to potential difference at the shunt. Potential difference at the galvanometer is equal to potential difference at the shunt. That is VG, is potential difference at the galvanometer will be equal to potential difference at the shunt. And from Ohm's law, this is the key to finding the value of the resistance of that low resistance wire, which is potential difference at the galvanometer is equal to potential difference at the shunt. Now, for Ohm's law, you know that V is equal to R. Again, here is equal to R. Where this arrow will be the resistance of the galvanometer. So we say ROG, the resistance of the galvanometer. While the arrow is the resistance of the shunt, which is what we are actually looking for, the value of ROS. Now, what about I? You know that when two components are connected in parallel, they don't have the same current. The same currents are not flowing through them. So this I will be the current flowing through the galvanometer. While this current will now be current at flowing through the shunt. Will now be current flowing through the shunt. Now, to better understand that, let's say I is equals to IG. I subscript G is current flowing through the galvanometer. And like we said, from the question, the galvanometer, when give a full scale deflection, is when you have a current of 0.05 ampere. So the current the highest current is 0.05 ampere. Now, RG, which will now be resistance of galvanometer. Resistance of galvanometer, which is equal to what? Which is given to the what? 5 ampere. While IS is the current flowing through the low resistance wire or shunts. Now, mind you, this current flowing through the shunt is also current drop, because the total current that is meant to flow through the whole circuit is 2 ampere. Now, this 2 ampere is broken down into 2 parts. Some will flow through this first, the galvanometer, and others will flow through the low resistance wire. So it's a current drop. So we already know the current that will flow through here. The others that will not flow through here out of 2 ampere. So instead of you can say current flowing through the low resistance wire or shunt, or current drop, because you know the total current that is meant to flow through the what setup. So current drop. The full current that is meant to flow through the current, the circuit is 2 ampere. 2 minus the one that has flowed through here is 0.05. So what is left will now be what will flow through the what? Low resistance wire. Again, IS is the current that is flowing through the what? Shunt, and it's still the current drop, because you know that 2 ampere is flowing through the resistor. So to get the current drop, you now say 2 minus what? 0.05 is the current that flows through it. You now remove it from the total what? Current to get the leftover current. That will, because if you add the current flowing through here and flowing through here, you now get total current in the what? Flowing through the what? Setup, as we have done, just the way we used to do. When you say we now add the first current flowing through the first resistor, second resistor, third resistor, you now get the total. Good. So it's still the same idea. Now 2 minus 0.05 give us 1.95 ampere. So the current flowing through this low resistance wire is 1.5 ampere. 1.5 ampere. Now let's continue. IG, we say it was 0.05 times RG is what? 5, while RIS is what? 1.95 times ROS is what we are looking for. RS, we are looking for the low resistance wire. Now you divide both sides by 1.95, so now the 0.05 times 5 divide 1.95. ROS will give us 0.128 ohms. So you see that value is very low. Just the way it is said in the definition, it's always a low resistance wire. A shunt is a low resistance wire connected in parallel to a galvanometer to help the galvanometer to measure large current. So in the sense that you're converting a galvanometer to an ammeter. In the condition that you usually ask is what is the value of this resistance that you can help to convert this galvanometer to an ammeter. What is the resistance of this wire you can connect in parallel to be able to measure a large current that the galvanometer is not designed to measure? And to start your calculation, the key is to write this. Potential difference at the galvanometer is always equal to the potential difference at the shunt. Potential difference at the galvanometer is equal to potential difference at the shunt. Then you know that potential difference is denoted with V, and V in Ohm's law is equal to I arrow. Yes, the I arrow. The I is the current flowing through the galvanometer. I arrow is the resistance of the galvanometer. IS is the current flowing through the what? Resistor, the low resistor. And to get it, we use the idea of current drop. The total current that was flowing through this example was 2 ampere, that was the one that is flowing through the what? Galvanometer. With that, you can decipher, destroy any question relating to shunt, or be able to calculate a low resistance wire. You can connect with a galvanometer, be able to convert it to an ammeter. Quickly, let us go to a multiplier.